Hi, this is Mr. Ralphs, and I'm going to be doing a little video on solving absolute value equations. And hopefully I can write neatly here. Absolute value equations. Please excuse my messy writing. Okay, so first of all, let's take a little background on absolute value graphs and what absolute values are. Basically, if you have something like an absolute value of x, the modulus of the absolute value is always going to be positive x. So actually that equal sign should be greater than. So let me just erase this here. So this is always going to result in something greater than 0. So everything positive. So if we take a look at the graph of y equals x, we've got the y-axis here, we've got the x-axis here, and we'll do the graph of y equals the absolute value of x. So when x is positive, obviously all the y values are going to be positive. And when x is negative, normally, if it were y equals x, normally if x were positive, negative, y would be negative. But with the absolute value, the modulus of that is going to be positive. Therefore, all the y values are going to remain positive no matter that the x values are negative. So that's the general graph of an absolute value graph, or an absolute value function, where the modulus is always going to end up being positive. So let's take an example to solve absolute value equations. Let's do a little example here. We'll say the absolute value of x plus 1 equal to 5. Okay, so now like we said over here, when x is positive, nothing really happens here. Y is just always positive. So there's going to be two cases. As we can see, there's when x is positive, y is positive. When x is negative, y is also positive. So if we take a look at case 1, when the modulus is positive, when inside the absolute value is positive, when x plus 1 is greater than 0, nothing has to be done. So we can just solve that. X plus 1 equals 5. And we rearrange this and we see x equals 4. Now, what happens when over here, when x is negative, if we just had the graph of y equals x, when x is negative, y would also be negative. Well, what's one way that we can change these negative y values into positive? Well, basically by vertical reflection, by multiplying by -1. So in case 2, this is when inside the absolute value sign is less than 0 or negative. Then we have to multiply that whole thing by -1. And by doing so, that makes it positive. Okay, so if it were negative, we multiply by -1, which then makes it positive. So we get negative x minus 1 equals 5. Negative x equals 6. Therefore, x equals -6. Okay, so that's the solution of when the absolute value of x plus 1 equals 5. We have 2 points where that is true, and that's at x equals 4 and x equals -6. Now take a look over here, and here's the graph for that. Here's the graph of the absolute value of x plus 1. We see it's been translated to the left 1 unit from the origin, and all the values are positive, and we see that the point of intersection where y equals 5 and this graph of the absolute value of x plus 1 excuse me, is at x equals -6, and y equals 5. There's the point, negative 6, 5. And the other value of x value is 4. And the y value, of course, is 5.